Good afternoon. I'm very pleased to be addressing you today. Archer is perhaps best known for its work in developing a quantum chip that could potentially enable some amazing things for your mobile phones and your laptops. And we call this technology our 12CQ chip. But while this development work is really an intense focus at Archer, it's not the only thing we do as a semiconductor company. We're also developing a biochip, which is also an advanced device based on really it's the pioneering scientific work of our staff. And for those of you who are new to Archer, today I would like to introduce you to the global scale of opportunity that our technology represents. And to our longer term shareholders tuning in today, I wanted to really delve deeper into the way that we're going about doing this work, this wonderful work that we're doing. Disclaimer, but the images are ours. I mean, these are our staff working in the places we work in, the facilities we use, the tools that we operate. They're not stock images. So it's all real, people in bunny suits. So I think this slide really summarizes why we're in a position today to create value at Archer. At Archer, we're well funded into the foreseeable future. And we have a focus on technology development at the cutting edge, not the trailing edge, the cutting edge, in growing critical industries. And we're working towards commercialization of advanced technology, these advanced technologies, by protecting our IP and by partnering with global players, both small and large. Right? So before we get right into quantum, I think what's helpful here is to give you some background and some context of where Archer sits in the broader semiconductor industry and where Archer operates. Archer currently focuses on the initial stages of the industry product lifecycle. That's really the R&D and the work that precedes the R&D. It's well understood that because of the link to performance of the high tech, these are the areas where there are potentially some of the largest opportunities to capture value, right? It's unlike many other industries where you see that kind of downstream. But for example, I wanted to focus on quantum computing technologies to give you a little bit more of an example. Current quantum computing or quantum proposals rely on custom-made fabrication. Right? It's unlike modern computing circuits where they're manufactured in and using well-established industrial semiconductor facilities, right? Integrating things that we call qubit materials with existing industrial scale foundries is really a significant challenge in developing quantum chips. And Archer, I guess, well, the good thing is we've already begun addressing these challenges together with tier one industrial semiconductor foundries and institutes in the US and Europe and around the world. So as you would appreciate, this is very complex work, right? And success requires very, very talented people with particular skills that are very rare. I really cannot emphasize that enough. Right? And they include nanotechnologists, physicists, chemists, biologists, theoreticians, material scientists, foundry fabrication engineers, you name it. But I'm very proud to say that the purpose of showing you this slide is that we do have these people at Archer. And since the start of 2022, since the start of the year, we've been on a recruitment drive. And we've been able to attract pioneers in the field, and we've really grown into a team that I strongly believe can rival any in the world. Our progress to date, the devices that we've built and the patents that we've generated really testify to this. And I'm quite confident about our ability to execute on our plans moving forward. But if there's one thing that I wanted to remind you of today, really is that Archer is one of very few companies in the world developing a qubit processor, a quantum processor, and the only one listed on the ASX doing so, to the best of my knowledge. So the question you may have is, but why are there so few companies developing qubit processors, right? what's hard, but I want to emphasize that really it's not a fast follower field, right? It's not something you just get out of bed and put your slippers on and say, we're going to go make a qubit processor. It's a lot more difficult than that. And nor does some easy, universal solution exist already, right? It's a nascent field with few feasible approaches to this thing called quantum processing. And in other words, there's no silver bullet. Okay, there's this kind of, you need to really grasp that it's incredibly difficult to be in the quantum race, let alone be at the forefront of what is happening in quantum technology. You require access to some of the highest of high-tech infrastructure, the most talented minds, and really an obsessive pursuit of scientific and technical endeavor at the very limits of what is possible today, right? And I think you'd be quite surprised that apart from the leaders in the field at Archer, right, there are just how many Aussies there are around the world at the forefront of this endeavor. So really exciting to be in this position. And it kind of just really returns me to my earlier reference around the qubit processor. And it's the most critical part of the quantum machine. And Archer has, in this regard, a very specific focus. We're positioning ourselves and really methodically advancing our 12CQ qubit processor technology where there are clear benefits for mobile use. Right? And importantly at Archer, we're not playing catch up. Technologically, we do have a unique value proposition that holds up as a world first. And it's our qubit processor could potentially allow for quantum computation at normal conditions. Integrated, and this is an important thing. I know, Mark, you're saying room temperature, but the other part of that is that you're able, potentially to easily integrate this into modern electronics, right? So taking the two together. And so this for quantum technology is really an astounding proposition, but one that we can back up with many years of R&D. But we also have an understanding, we're realists, right? We have an understanding that this emerging technology is widely expected to solve some very valuable problems that today's technologies just can't solve and never will. That just really clear on that. And I'm sure that you'll agree that this is a competitive advantage that's worth protecting and that this is a technology that's worth developing. I mean, right? So, I mean, for us, we believe that, and that's exactly what we're doing. So, and we're doing this by making real quantum hardware, right? Devices that scientists only really begun to imagine just a few decades ago. Yeah, say a few decades ago. Time flies, right? And this device here on the right, I actually have it with me, so just come up to me later and I can show you that it's real, right? The device that I want you to have a look at the bottom right corner, there's a little kind of square, just maybe the pointer. Yeah, I'll get over here. This thing here, that's the device. Okay, it's like 0.5 mil by 0.5 mil. The qubits sit in there, right? So the device you see here is really a primer for this transformative technology. It's something that we built on the way to our ultimate goal. This is a result of over a decade of world-class R&D. It's direct proof that cuts through a lot of the hype surrounding quantum, and it really supports this exciting possibility of quantum-powered mobile devices. But really, it's given us the confidence to say that we can do something special. And fundamentally, at Archer, I do believe that our 12CQ chip technology could change it for the better, the way that we transact and the way that we communicate with each other. Fundamentally, if you want to poke into my brain, right, just keep hold of that sentence. I think, but the key for Archer at this early stage is really in positioning our technology where there are clear benefits for mobile use, but also with the understanding that this is an emerging technology. And right, so there's still a lot more that we need to do, and we are doing it. But as I showed kind of on the previous slide, there's no mass adoption of quantum computing yet, right? No one has really cracked it. However, people are not actually doing this for fun, as Mark was talking about earlier. There's a big demand for this technology once it's available. I'm probably a little bit more politically correct in the way I'm saying it. And there is a demonstrated commitment by the biggest economies in the world, including our own, that it's going to happen, that quantum is going to happen. Now, I believe really the excitement around quantum tech is its promise to impact almost every sector that's currently dependent on or will be dependent on computational power, an increase in computational power. But the important thing to note is that to unlock all this potential value, the technology hardware, I'm not talking about software, it's the hardware, right? The hardware needs to mature, and specifically the qubit processor, that needs to mature, that needs to be developed, right? And yes, top corner here, I'm sure you would agree, 900 billion US dollars is a large number. But bear in mind, this is very difficult work, and quantum processing devices are some of the most complex products to develop, right? So we have to then really take an over-the-horizon view of what we do. We have to anticipate change in the sector. We have to understand the sector, and because it is such a key enabler for so many other industries. And each of these sectors could benefit tremendously with the advent of quantum technologies. Like quantum computing, as the solutions start to mature over the next 10, 20, 30 years, this type of anticipated penetration into a global economy, right? We're talking about global economies here, means that really it's no secret that quantum technology would give countries, nations, competitive advantages, not just, an enterprise, right? So I think this kind of touches on what Mark was talking about earlier. But there are already real uses for qubit processing, and uses in the shorter term on the way to the longer terms of full compute. It's already happening. However, it's limited in scope. But the last 5 years has seen a real extraordinary growth in quantum computing applications. It's huge. It's been massive. But quantum physics aside, we can talk about quantum physics later, personally. But what you do need to understand is the technology's power and its potential. I reiterate, this comes from the quantum processor, right? And I'd like to think that because of this, our 12CQ chip development is really a noble endeavor. Because if successful, I think along any point of the technology continuum, we like to call it, we could help solve some very long-standing and intractable problems that need urgent solutions in the industry. Using existing technology would just take too long, right? Just be very clear on that. People may ask, why do you work on technologies that will need to be developed over the next 2, 3, 5, 10 years? Because you cannot do it with existing technology, and it just takes too long with existing technologies, right? But I think the point I want to make here is that we're not incrementally improving the silicon chips in your devices, right? Qubit processor technology requires entirely new processor technology, new systems to be developed and to solve for these problems at the most fundamental level. And this is an example here of where qubits be used in quantum random number generators. And this is what I mean, where we go down to the most fundamental level of the technology that needs to be redesigned, right, in order to give you that advantage. But the advent of these types of quantum technologies, I think is widely expected to contribute to some of the highest impact solutions for managing a lot of these problems that I kind of just touched on before, including how we protect and secure our information. Again, this is not easy, but on the theme of governments and businesses, they now well understand that quantum technologies have the potential to solve problems way beyond the capability of conventional technology. Right? But to move on, I guess, it's quantum tech there. It's really exciting stuff. You'd appreciate, and especially for the introduction today, that as a semiconductor company, you can't stand still, right? And at Archer, we're constantly looking to expand our strategy, but keeping in line with our main focus. It's an important thing. And the development of our biochip, our Archer's biochip, fits with our focus. But it's important to really make a distinction here that we're focused on the chip and not the concept of point of care or these kinds of things. So it's the chip itself that's the paradigm. These lab-on-chip devices, biochip devices, well, they're miniaturized biomedical laboratories. This is where the world is today, at the very forefront of technology development, shrinking biomed labs onto a chip the size of your fingernail, right? Their entire labs built on a small chip. And the advantages of these labs or these biochips are listed here, but what this ultimately translates to is faster analysis times by the path labs and your practitioner, right? And look, yeah, we're not the only ones working on this type of tech, but there's a whole scientific journal dedicated to it, right? It's called Lab on Chip, right? So it's out there. But what we're starting to see is the field advance from the laboratory, no pun intended, to the hospitals and the testing centers and the clinics, right? But despite what really appears to be simple, hey, honey, I shrunk the kids kind of thing, there are huge barriers to entry in this field. It's not a fast follower field, right? But Archer has really made some significant progress in our technology development this year. And we've been protecting our IP along the way associated with this really interesting technology. But to really highlight kind of what we've done, these chip designs, they require, and we were discussing this with other members that are going to give talks that I was discussing this earlier, they require clean room facilities, they require talented people to fabricate these devices, because you're trying to integrate a chip made from materials that you don't find in the body, right? There are networks of microchannels that are hair thin, nano-sized electrodes, ultrasensitive sensors made from atom-thick materials, electronic circuits that have to withstand water, right? All placed in strategic locations on a chip and have it function. It's difficult work, but we're doing it. And we're making significant advances as our team has grown this year and our access to facilities expands. Yes, that's a CAD drawing, okay, but that's the real thing on the top. So it's just a little section here, right, up there, which shows a wettable graphene field effect transistor. Very difficult to make. So in other words, kind of very miniaturized, very small, very impressive work by the team. But I hope that I've painted a good picture of what we do as a high-tech semiconductor company in Australia. And just in conclusion, I'm wrapping up, Mark, conscious of time. Just in conclusion, I do want to say that today Archer has a solid development track record, right? We're well-funded. We've assembled a great team. We've created new technology. We've been granted several patents around the world in the US, Asia, Europe, Australia. And we have access to the facilities and the infrastructure to move forward confidently and competently, right? And our success today is not a result of some, it's not overnight. It's not some single development or a single idea, right? It's not a single thing. And at the same time, we haven't done this alone, right? Our success is really due to the quality of our people, the quality of our management, and the excellence of the organizations that we work with. So I hope that today I've conveyed to you some of the excitement about the things that we're doing and how things are really coming together at Archer and how eminently worthwhile I believe it is. So on that note, thank you very much for your attention.